Welcome to the AI Coach by Anil Nathu. Today, we're embarking on a fascinating deep dive into a topic that sits at the very heart of human progress: scientific discovery. For generations, this process has been incredibly human. Imagine tireless researchers, hunched over mountains of articles, painstakingly sifting through data, desperately trying to spot those elusive gaps in our understanding, that perfect next question to ask.
It's a monumental task.
It really is, especially with the sheer volume of information exploding around us and the relentless pace of technological change. It feels like we're constantly searching for a faster, smarter way to innovate, doesn't it?
It absolutely does. And this is precisely where the breathtaking promise of AI, particularly large language models or LLMs, enters the picture. We've witnessed LLMs achieve truly astonishing success in fields that demand immense logical rigor and precision, like mathematics, proving incredibly complex theorems, and even writing highly functional, error-free code.
Right. The capabilities are just incredible now.
They really are.
Yeah.
These aren't just incremental improvements. These are capabilities that often match or even surpass human experts. So if they can handle that level of complexity, the natural question becomes, can they also revolutionize something as abstract, as nuanced, as fundamentally creative as generating novel research ideas?
Can they actually come up with something new?
Exactly. The potential for these models to move beyond mere information processing into a true intellectual partnership with humanity is genuinely fascinating.
And here's where the story gets really compelling, because while that promise is immense, the current methods for evaluating these AI-generated ideas have some significant blind spots. The research we're diving into today highlights three major challenges that are, frankly, holding back LLMs from making truly groundbreaking, verifiable contributions. First, there's the pervasive issue they call data leakage.
Ah, yes, data leakage. It's a big one.
Think about it this way. If an LLM was trained on practically all the world's published information up to a certain point, and then we ask it to discover an idea that was published before that cutoff date, is it truly discovering something new, or just regurgitating information it already saw during its training?
Right. It makes it incredibly difficult to assess genuine novelty in that scenario. Is it creation or recall?
Exactly. How do you truly test novelty if the test subject already knows the answer?
Precisely. And building on that, the second challenge is the absence of complete ground truth. Many of the existing ways we try to evaluate AI creativity are limited to just assessing the titles and abstracts of generated ideas.
Just the summary, basically.
Yeah, just the surface. But a truly impactful research idea is so much more than a catchy title or a brief summary. It encompasses the deep motivations behind the work, why it needs to be done, and the detailed experimental steps required to rigorously test it how you'd actually do it.
So if you're only looking at the title and abstract,
You're missing crucial components. It's like trying to judge a complex gourmet dish by just reading its name on the menu. You miss the chef's inspiration, the specific ingredients, the intricate cooking process. Your assessment is inherently incomplete.
that makes sense. And then we hit the third challenge: a limited scope of feasibility analysis. Can these brilliant AI-generated ideas actually be done? Are they practical, viable in the real world?
That's the million-dollar question, isn't it? Current evaluation methods often struggle with providing a quantitative, rigorous assessment of feasibility. And this is often because they're constrained by how the prompts are designed for the judge model.
How so?
Well, if you don't explicitly ask for and allow the AI to evaluate the nuts and bolts of practicality, resources needed, technical hurdles, existing methodologies, then the assessment remains superficial. It's tough to get a concrete, measurable answer to, can this actually work?
So these are some pretty significant hurdles: data leakage, incomplete ground truth, limited feasibility checks.
They really are. But to courageously address these critical limitations head-on, our sources highlight a truly groundbreaking solution: AI Idea Bench 2025.
Okay, AI Idea Bench 2025. What is it exactly?
This isn't just another collection of data. It's presented as a comprehensive framework and data set specifically engineered to quantitatively evaluate and compare AI-generated ideas, specifically within the AI research domain and from multiple rigorous perspectives.
So a structured, verifiable way to gauge idea quality.
Precisely. Both by checking alignment with the true content of original published papers, what they call the ground truth, and by judging ideas against general reference material, providing a broader, more objective context.
Okay, I'm starting to see how this tackles those challenges.
It's a very clever design.
So what does this all mean for you, our listener? Our mission today is to unpack AI Idea Bench 2025. We're going to dive into exactly how it works, What makes it so unique in tackling these challenges? The surprising insights it has already revealed about AI's creative capabilities, and, most importantly, how this groundbreaking work can reshape your understanding and approach to scientific discovery and innovation. This really embodies the forward-thinking approach championed by AI coach by Anil Nathu. Let's get to it. Let's begin by deepening our understanding of the landscape. For centuries, the process of generating new scientific ideas has been almost entirely human-driven.
Labor-intensive.
Totally. Think about those iconic images of scientists in labs surrounded by stacks of books and papers, or maybe a team huddled around a whiteboard furiously brainstorming.
Right. Meticulously reviewing existing studies, poring over results, identifying shortcomings.
And then, through a flash of insight or maybe just laborious deduction, proposing novel avenues for investigation.
It's this deeply human, painstaking process that has led to every major breakthrough we know, from understanding gravity to sequencing the human genome.
That's the historical context. But the scale of scientific literature has absolutely exploded.
Oh, it's unbelievable now.
Yeah.
What was once a vast but perhaps navigable ocean of knowledge has become, well, an unnavigable cosmos is a good way to put it.
Yeah, the sources say the growing complexity and sheer volume of scientific literature, combined with the swift pace of technological evolution, has made this human endeavor increasingly daunting.
It's simply becoming too much for any single researcher or even large team to keep up with comprehensively.
You can't possibly read every paper published in your field anymore, let alone all related fields.
No way. It's a classic case of information overload.
And this is precisely where the conversation pivots to the thrilling potential of large language models.
Right, because of their incredible leaps forward, particularly in areas like mathematics, theorem proving, coding.
Yeah, the stuff we mentioned earlier.
Exactly. There's a strong and growing belief that LLMs could play a pivotal role in facilitating more abstract and creative research idea generation tasks. This isn't just wishful thinking. This potential has garnered substantial attention across academia and industry.
So the idea is that LLMs could become super efficient research assistants.
Kind of, yeah. Sifting through that cosmic volume of data, spotting connections, identifying gaps that humans might easily miss, acting as a profound accelerator for innovation.
It sounds amazing. But as we touched on, there are those hurdles.
Indeed. And understanding these challenges is absolutely crucial to appreciating the ingenious solutions offered by AI Idea Bench 2025.
Okay, let's break them down again. The first one, data leakage. This sounds really tricky.
It is, and arguably the trickiest to detect. Many existing approaches aiming to generate novel research ideas rely on incredibly powerful models like, say, GPT-4o. The issue is that these LLMs have a knowledge cutoff date, a specific point in time into which their training data was collected.
Like October 2023 for GPT-4, right?
Exactly. So if the evaluation of the generated idea is reference-free, meaning there's no independent way to check if the idea actually existed or was published after that cutoff, well, you're in a bind.
Because the AI might look creative.
But it could simply be regurgitating information it already saw during its training, because that information was published before its knowledge cutoff.
It raises that fundamental question again. How do you truly test for genuine novelty if the test subject might already know the answer from its training?
It's like giving a student an open book exam, and then claiming their perfect score demonstrates deep understanding, when they might have simply copied from the text.
Right. It's not about the AI cheating, but about our evaluation methods maybe failing to isolate true creativity.
Precisely. Which leads to the second challenge.
Yeah.
Incomplete ground truth in current evaluation efforts. Often, when researchers evaluate LLM-generated ideas, their assessment is confined to the generation and assessment of titles and abstracts.
Just the summary again.
Yeah. While those are important for summarizing, they don't capture the full essence of a research concept. A complete, valuable idea includes
Not just what you're proposing, but why. The motivations.
exactly the underlying motivations, the problems you're solving, and how you realistically plan to do it on. The detailed experimental steps, the methodology. By omitting these crucial components, current evaluation methods yield incomplete reference points.
Like judging the building just from the drawing, not the blueprints.
That's a perfect analogy. You wouldn't prove it based on a catchy name and a pretty drawing. You'd want the blueprints, the structural calculations, the materials, the schedule. Yeah. Without that full picture, your assessment of its viability and originality is inherently limited.
Okay, got it. And finally, we arrive at the limited feasibility assessment.
Right. It's one thing to have an AI generate a brilliant novel idea, but quite another to determine if it's actually practical to implement. Can it genuinely be done?
And the current methods struggle with this.
Yeah, our research points out a deficiency in the quantitative assessment of the feasibility of ideas. This often comes down to limitations in the design of the prompts in the judge model itself.
Meaning the judge isn't asked the right questions.
Essentially, if the prompts aren't designed to rigorously probe the viability, asking granular questions about resources, technical challenges, supporting methodologies, then the evaluation can only be superficial. It's incredibly difficult to get a concrete quantitative measure of can this actually work without that depth.
So these three challenges really paint a picture of why we need something better.
Absolutely. And this is precisely what AI Idea Bench 2025 sets out to solve. It directly addresses these three challenges head-on with its unique data set and a framework designed to quantify and compare ideas generated by LLMs from multiple perspectives.
It moves beyond just subjective feelings about an idea.
Yes, it bravely moves beyond abstract subjective judgments to provide a concrete, measurable benchmark for AI creativity. This comprehensive framework is divided into two key evaluation components.
Okay, what are they?
First, it rigorously checks for alignment with the ground truth content of original papers.
Okay, that hits the data leakage and incomplete ground truth problems.
Exactly, by providing a verifiable, objective reference. And second, it performs judgment based on general reference material.
What it allows for.
A broader, more objective, and crucially, a more in-depth feasibility analysis.
Wow, okay. That dual approach sounds really robust.
It is. The developers emphasize that this framework is poised to become an invaluable resource for gauging and comparing diverse idea generation methods, ultimately propelling the automation of the scientific discovery process.
This isn't just an incremental step. It feels like a foundational leap.
It really does. And this is a core principle reinforced by the philosophy of AI coach by Anil Nathu, ensuring that AI tools built for discovery are founded on robust, verifiable, and truly innovative foundations. Not just clever mimicry. It's about empowering genuine, reproducible breakthroughs.
Building a benchmark as ambitious and robust as AI Idea Bench 2025 is no small feat, especially when you're trying to assess something as complex as original research ideas.
Definitely not.
One of the trickiest parts they face was what's often called the ground truth problem in AI research. How do you define what's correct for a new idea?
That's the core issue. Normally, for a machine learning data set, you'd want paired data sets, where you can definitively say this specific prior literature directly led to this particular problem identification or new idea.
But real science isn't usually that neat, right?
Not at all. In the messy, human-driven world of real scientific discovery, it's incredibly difficult to trace a new idea back to a neat, finite set of inspirational papers. Innovation is often diffuse, multi-source, nonlinear.
So how do you establish a true ground truth for novelty if you can't perfectly map the inspiration?
That's the central conundrum. So, AI Idea Bench 2025 employs an ingenious alternative approach. Instead of trying to work forward from inspiration to idea, which is complex to map definitively, they seek out papers from the literature that explicitly identify problems.
They work backward.
Essentially, yes. They take already published, impactful research papers and treat the problems those papers solved as the verifiable ground truth for what a good, innovative idea looks like.
Ah, that's clever. So the ground truth is a solved problem documented in a real paper.
Precisely. This allows them to build a verifiable data set even without a perfect forward causal chain. It's a very clever inversion of the problem.
That is brilliant. Now let's get into the nitty-gritty of how they meticulously curated this impressive data set. They selected what they call the target papers.
Right, the ground truth papers.
Which serve as the definitive ground truth against which AI-generated ideas are measured. And this wasn't just any random selection, was it?
No, far from it. They focused on highly influential cutting-edge works from the absolute top tier of AI conferences. We're talking the top 2% of ICLR 2025. Highlights from CVPR 2024, oral presentations from ECCV 2024, spotlights in oral presentations from NeurAPS 2024, as well as spotlights in oral presentations from ICML 2024.
Wow.
And also key papers from NAACL 2024, EMNLP 2024, and ACL 2024. This ensures they're capturing the very forefront of AI research. the best of the best.
And crucially, they added that safeguard against data leakage.
Yes, absolutely vital. They demonstrated their commitment to real scientific rigor by setting a strict knowledge cutoff date of October 3, 2023.
Before GPT-4o came out.
Exactly. That date is significant because it was prior to the public release of GPT-4o, the base model used for idea generation in their experiments. This means the LLMs being tested couldn't possibly have seen these target papers during their training.
So any match isn't just memory recall.
Correct. This meticulous selection process is absolutely vital to avoid inaccurate insight evaluation caused by potential data leakage, ensuring that any novelty the AI demonstrates isn't just a memory trick. In total, they compiled an impressive 3,495 papers to serve as this dataset's robust ground truth.
That's a massive, high-quality, and carefully vetted collection, a huge undertaking.
It really is.
So they have the gold standard of target papers. How about the inspiration papers, the ones fed to the LLMs?
Right, the inputs. The process for identifying these is also carefully structured. They use something called SciPDF parser to extract content from papers, and then leverage DeepSeek v3, another AI model, to tally up the cited literature within those papers.
So using AI to find potential inspirations for the target papers.
Yeah, giving them a data-driven starting point for what might have inspired the original authors.
But they didn't just rely on automation.
No, and this is key, I think. They added a critical human touch. From the top 10 most highly cited works identified by DeepSeek v3, 2 seasoned researchers meticulously evaluate that shortlist and select 5 studies deemed both feasible and reasonable as sources of literature.
So human experts vetting the AI's suggestions for relevance and quality.
Exactly. It's about ensuring the quality and relevance of the inspirational inputs, mimicking how discerning human researchers actually gather and select their foundational knowledge.
Okay, so target papers, inspiration papers. But they don't just feed the whole text to the LLMs, right? There's pre-processing.
Yes, and it's absolutely crucial. The research emphasizes its importance because idea generation primarily relies on understanding the motivation and experimental procedures, not necessarily every single word of an entire paper, which might include lots of background, related work, acknowledgments, etc.
So they extract the core parts.
Right. These specific, highly relevant parts are carefully extracted from the inspirational papers. And for the target literature, the ground truth, they go a step further. They summarize the problems addressed, identifying the fields in which they were solved, as well as the methods employed.
Distilling it down to the essentials.
Precisely. This distillation ensures that the ground truth is presented to the evaluation system in a clear, concise, and focused way.
And here's another clever detail that caught my eye. They anonymize the methods, omitting their specific names while providing detailed descriptions of the methodological steps. Why do that?
That's a fantastic question, and it's a critical nuance. By anonymizing the method names like ResNet or Transformer, they prevent the LLM from simply pattern matching a popular name.
It has to understand the concept.
Exactly. It forces the evaluation to be on the concept of the method, its underlying functionality, and how it addresses a problem rather than just its well-known label. This helps prevent bias and pushes the AI to think about the mechanics of innovation. Anonymized topics also facilitate broader idea generation by focusing on the underlying problem, not specific jargon.
That makes a lot of sense. It forces deeper understanding.
It really does.
When you connect all these meticulous steps back to the bigger picture, this careful data set construction stands in stark contrast to much of the related work out there.
Definitely. Many existing data sets, as this research critiques, lack verifiable ground truth and are predicated on open-ended evaluation paradigms.
Which leads to
potential data contamination issues, because they don't sufficiently account for the LLM's training data limitations, like that data leakage problem.
So AI Idea Bench 2025's approach is really trying to fix that.
Precisely. Its meticulous approach, especially with a stringent knowledge cutoff and focus on problem-identifying papers, helps avoid inaccurate insight evaluation caused by potential data leakage and incomplete representation of the literature. This unwavering commitment to rigorous data hygiene and verifiable ground truth means this dataset is a foundational stone for robust AI research.
It sets a new standard.
I think so. It's a standard that the AI coach by Anil Nathu philosophy champions for building truly reliable and innovative AI systems. It's not enough for AI to be creative. Its creativity must be verifiable, accountable, and built on a solid foundation.
So we've explored this meticulously crafted dataset. Now comes the real challenge. How do you actually measure the quality of an AI-generated idea in a way that's objective and comprehensive?
Right, the evaluation framework. This is where AI Idea Bench 2025 truly shines.
It's divided into two key components, you said.
Yes, to provide a holistic assessment, comparing against that carefully established ground truth and evaluating based on broader reference material.
And this is where it gets really interesting, how they quantify things like creativity and feasibility.
Exactly, because they've devised some incredibly clever ways to approach evaluating something as abstract as creativity, novelty, and feasibility in AI. It's not just subjective judgment, it's quantitative and multifaceted.
Okay, first up is the ground truth test. The purpose here is to objectively assess the generated results.
Correct. By directly comparing them to the motivation and experimental framework of the actual real-world target papers. It's like testing how well the AI can predict what a successful research paper would have looked like.
And the first method is the idea multiple choice evaluation, IMCQ, like a quiz.
Exactly. Think of it as a quiz test. Here's the setup. The correct answer, AC, is the actual motivation, MT, and experimental framework, ET, from a target paper. Then they create 3 distractors, incorrect but plausible alternatives.
How do they choose those?
2 distractors are papers that have the closest conceptual alignment, L1, L2, to the target paper, but aren't the exact one. And 1 distractor, L3, has the highest degree of similarity to all target papers in the dataset.
So, related but wrong, and generally plausible but wrong.
Precisely. The LLM's task is then simple. Select the correct answer from these 4 choices.
And what does an LLM picking the right answer in this quiz really tell us?
It measures whether the LLM can transcend the limitations of its input and actually approximate that true ground truth. If it can consistently pick the correct original idea, even with tricky alternatives, it suggests a strong grasp of the underlying problem and a sophisticated understanding of how a successful solution is structured.
It's not just generating an idea, it's showing it can generate one that looks like a successful one.
Exactly.
Okay, next they have idea-to-idea matching, I to Y. This sounds more detailed.
It offers a more nuanced lens. Here, an LLM acting as a judge directly scores the similarity between a generated idea and the target paper's content on a scale of 0 to 5. Higher score, better match.
And it looks at specific criteria.
Yes, very specific. For judging the motivation, the LLM looks at things like, is it solving the same underlying problem? The core issue analysis. Does it fit the same research domain? Contextual alignment. Does it propose similar foundational ideas? Structural theoretical overlap.
So really digging into the why and the what.
Exactly. And for the experimental design aspect of I2I, the LLM judges, does it propose a similar approach? Structural similarity? Is it grounded in similar scientific principles? Theoretical consistency? And does the experiment directly address the core problem? Problem-centric focus.
This goes way beyond keywords, into the actual logic and structure.
It really does. It gets into the actionable steps.
And finally, for this part, idea-to-topic matching, I2T.
Simpler, but crucial. This also uses a 0-5 score to assess how well the generated ideas align with the specified topic of the target paper.
Just checking if it stayed on topic.
Essentially, yes. Checking for thematic consistency, ensuring the AI isn't just generating a good idea in a vacuum, but one that is directly relevant to the problem it was tasked with solving. It keeps the AI grounded.
Now, onto the second major component, evaluating with other references. Why is this needed?
It's designed to address the uncertainties that arise when LLMs judge abstract concepts like good or novel without external benchmarks. This encourages critical thinking and provides broader context, moving beyond just matching one ground truth paper.
Makes sense. So the first method here is ideas competition among baselines, IC, an LLM showdown.
That's a great way to put it. Basically, DeepSeek v3, acting as a judge, conducts pairwise comparisons of different baseline LLMs, like AI researcher versus AI scientist. It assesses them across 6 aspects: innovativeness, importance, quality, feasibility, clarity, and topic relevance.
How does the scoring work?
For each comparison, the winner gets 3 points, the loser gets 0. The total score for each baseline is then summed up. What's fascinating here is how they turn abstract qualities like innovativeness into a quantifiable competitive score by having AI judge AI.
It's like a simulated peer review process using AI judges.
Exactly. Providing a comparative ranking without relying on a single fixed correct answer.
Very clever. But what about assessing true novelty, especially given that knowledge cutoff issue?
That's where novelty assessment, or NA, with reference to other literature, comes in. This directly tackles that knowledge cutoff limitation. Here's the clever bit. It extracts keywords from the generated ideas topic and then establishes a timeline, with October 3, 2023 as the pivotal cutoff date.
Okay.
Papers published before this date are considered historical, and those after are contemporary. The novelty score, SN, then uses a formula that weighs how different the AI's idea is from historical papers, so TV is, against how aligned it is with new emerging research, data is, and how influential that new research is, CC, based on citation.
Whoa, okay. So the formula is SN at ease 1 plus C dia, CC 1 plus seat redia.
That's the one. So higher novelty comes from being distant from old ideas, somewhat aligned with influential new ideas.
So it's not just about being new, but being relevantly new, connected to the cutting edge.
Precisely. It's identifying ideas that are genuinely fresh and resonate with the most current and influential thinking. Truly timely and forward-looking. And crucially, this method shifts the focus to the ideas presented in each paper, not just abstracts, making the novelty assessment much more comprehensive.
Okay, that's impressive. Finally, feasibility assessment, FA, with reference to other literature. How does this work?
The goal here is to determine if the proposed experimental approaches are grounded in established, effective methodologies. Are the building blocks sound?
How do they figure that out?
They do this by recursively subdividing the motivation and experimental plans into their smallest concepts, like breaking a recipe into individual ingredients and steps. Then, they identify published papers that reference these fundamental concepts. These papers are the reference methods.
And the logic is?
The core principle is intuitive. The greater the influence, measured by the number of citations of these reference methods, the higher the feasibility of the AI-generated idea.
So if an idea uses well-established, highly cited components, it's deemed more feasible.
Exactly. It's grounded in proven techniques.
But citations can be skewed, right? Old papers might have tons.
Good point. And they account for that. They introduce influence normalization, NFN, using a formula. NFN is EX plus 1, where X is citations and E is an impact factor, set to 50.
What does that normalization do?
It prevents extremely highly cited papers from dominating the score too much. For example, 35 citations gets an influence score of 0.5, frequently discussed. 100 citations gets 0.9, most innovations built upon it. It gives a more balanced view of influence.
And they also factor in time decay.
Yes, absolutely. They introduce another new influence evaluation equation, INF, that accounts for decay over time. Basically, the impact of papers from the last 2 years is calculated normally, but older papers have their annual impact adjusted by dividing it by the difference in years from the current year.
So recent influence counts more towards feasibility. Makes sense.
It does. The final feasibility score, SF, is the average normalized time-decayed influence of all relevant reference papers. It ensures we're pinpointing methodologies that are actively influential right now.
Wow. This whole framework is incredibly detailed and quantitative.
It really is. It allows for an unparalleled quantitative assessment of AI-generated ideas, moving beyond subjective opinion.
It provides a robust, data-driven benchmark.
Exactly. And this kind of rigorous, verifiable evaluation is precisely what propels the capabilities of systems like the AI Coach by Anil Nathu. It ensures the insights and tools provided are built on truly solid ground, understanding what makes an idea not just novel, but also genuinely viable.
All right, now that we understand the intricate design of AI Idea Bench 2025, the data set, the evaluation framework, it's time for the big reveal. Who actually generates the best ideas when put to the test against this rigorous benchmark? Let's talk results.
Okay, first, a quick recap of the data set used. That carefully curated collection of 3,495 high-quality papers from top AI conferences, CVPR, NeuroPS, ICM, AICLR, etc., representing the cutting edge.
Got it. And the baselines, the AI systems they tested.
They selected 4 leading approaches for comparison: AI researcher, AI scientist, SCIPA, and VeraCI. These are all fairly well-known systems in the AI community, each with its own approach.
And crucially, they standardized the underlying model.
Yes, this was vital for a fair comparison. They used GPT-4o 2024-1120 as the base model for all methods, unifying the knowledge cutoff date.
So any differences are down to the method, not the base LLM.
Exactly. That ensures performance differences are directly attributable to the specific idea generation methodology of each baseline. And they generated 2 ideas per inspiration paper for each model.
Let's start with the results from evaluation with target paper, alignment with the ground truth. Which models were best at matching successful existing research?
Here, AI scientists clearly came out on top. It demonstrates the highest degree of alignment with those of the target paper, especially in terms of motivation.
Meaning it's best at understanding why a successful paper was needed.
Precisely. It's exceptionally good at understanding and approximating ideas that are already known to be effective and highly relevant. It's almost like it can deeply understand the core problem and solution from those target papers. For example, in one case study about a conversational music recommendation system, AI scientists generated motivation was strikingly similar to the original papers. It explicitly mentioned how existing research hadn't fully integrated video understanding and multimodal representation for interactive tasks like music recommendation. It nailed the research gap.
That's impressive alignment. So AI scientist is great at figuring out what a good known idea looks like. But what about generating new stuff? Breaking away?
Interesting you ask. When it comes to departing from the constraints of the inspirational literature, specifically in the experimental plans proposing novel ways to tackle a problem, VirCI actually performed better.
So ViraCI is better at novel how-tos?
It suggests VirCI has a stronger ability to generate more innovative experimental approaches, maybe more out-of-the-box solutions, even if its initial motivation alignment isn't quite as high as AI scientists.
Interesting trade-off. But overall, they all stayed on topic.
Yes, the research notes that all baseline models display an exceptionally high level of consistency with the thematic focus of the target paper, according to the I2T metric. They all stayed relevant.
Okay, now let's shift to the evaluation with other references, assessing novelty and feasibility more broadly. Did a different leader emerge here?
Indeed, here, AI researcher significantly outperforms the other baselines in both the circular comparison IC and overall feasibility assessment FA.
So in the head-to-head competition and overall practicality, AI researcher won.
Yes. This suggests that AI researchers' generated ideas are often perceived as more robust and viable by other LLM judges. They hold up better across those 6 criteria, like innovativeness, importance, feasibility, clarity. They're seen as more practical and well-rounded overall.
But AI scientists still had an edge in novelty, didn't it, according to the NA metric?
It did, and it's a crucial nuance. While AI researchers' ideas might be overall more feasible, AI scientists demonstrate superior performance in terms of novelty NA and exhibits greater average feasibility at the step-level FPS within the experimental design.
Meaning
AI scientists might be generating ideas that are truly groundbreaking, high novelty, and whose individual experimental steps are highly viable, even if the overall package is judged slightly less feasible than AI researchers.
So maybe more cutting edge, but potentially harder to implement overall, yet the individual steps are sound?
That could be one interpretation. It implies a capability for generating truly innovative and actionable step-by-step plans, which is a powerful combination for discovery.
These results show clear strengths and weaknesses. Let's dig into why. What's AI scientists' secret sauce for that amazing alignment with target papers?
The research explains that the AI scientist uses large language models to score and re-rank all input papers based on their direct relevance to the specified topic.
So it filters its inputs intelligently first.
Exactly, thereby achieving closer alignment with the core ideas of the target papers. It curates the most relevant context before generating the idea. By filtering and prioritizing, it helps AI scientists zero in on what a successful idea looks like in that domain, like having a hyper-efficient librarian finding just the right books.
Makes sense. And what about VRC mitigating bias with its multi-round, multi-agent discussion mechanism? How does that work?
It's designed to simulate collaborative brainstorming. Instead of one AI working alone, multiple AI agents discuss, debate, and refine the idea over several rounds.
Like a virtual committee.
Sort of. This interaction helps mitigate bias during idea generation by exposing the idea to different perspectives or processing pathways within the AI. It suggests diversity of AI thought helps, much like human brainstorming benefits from diverse viewpoints.
Interesting. Can we effectively simulate collaboration with AI? That's a big question.
It really is.
Now, AI researcher excelled through iterative refinement. What does that look like?
It's quite fascinating because it closely mimics human iterative thought. AI researcher preserves previously generated ideas and employs multi-stage reasoning chains combined with self-reflection.
Self-reflection.
Yes, to iteratively refine and expand upon each idea, thereby enhancing coherence and conceptual stability. It doesn't just generate once. It looks at its output, critiques it internally, and builds on it, like a human going through drafts. The research mentions an example, buffer of thoughts, where AI researchers' experimental plan included steps like generate independent rationales, critique and cross-reference, synergize conclusion. That structure reflects its process.
That iterative self-correcting loop sounds powerful. But then there's SCIPIP, which had a limitation.
Yes, SCIP's core weakness,
Yeah.
identified in the research, is its inability to deconstruct the components of an idea.
It can't break the idea down.
Right. Even if it identifies a novel concept, it struggles to break it down into fundamentals, motivation, experimental steps, outcomes. This leads to outputs that lack a coherent structural framework and are difficult to interpret.
So the internal structure is missing.
Exactly. It highlights the critical importance of internal idea representation for an AI. If it can't structure the concept logically, it struggles to generate something coherent and actionable for a human.
That makes sense. It might sound okay, but lack the underlying blueprint.
Precisely.
Interestingly, the research notes that even if they don't always win on metrics, AI scientists and AI researcher provide more practical details.
Yes, they tend to incorporate specific algorithmic choices and detailed comparative strategies within their experimental designs. This offers more granular and actionable guidance in experimental planning.
That's a really practical lesson. The how matters, not just the what.
Absolutely. It's incredibly valuable for real-world researchers.
Finally, how they used external knowledge, like the Semantic Scholar API, also mattered.
Hugely. It played a big role in the performance differences. AI scientist, for instance, enriches the generation prompt by embedding selected supplementary literature, giving it more informed context from the start.
It reads relevant papers before brainstorming.
Kind of. AI researcher, in contrast, utilizes the retrieved literature solely as an auxiliary resource for evaluating novelty during the generation process, without incorporating it into the prompt itself. It uses external knowledge more for validation later on.
Different strategies. And SciPype and VRSC.
SciPype reconstructs an entirely new research background by synthesizing information from both the input and the retrieved literature, tries to build a fresh context. And VRSC, its dependence on a locally stored database devoid of real-time updates imposes a significant constraint on the novelty of its output.
So it can't access the latest research. That's a good handicap.
A huge one in a fast-moving field like AI. These differing approaches to external information directly account for the notable disparities in their performance.
This detailed analysis provides such valuable insights for anyone trying to use AI for idea generation.
Absolutely. It truly embodies the principles championed by AI Coach, by Yansheng, showing how understanding the mechanics of AI leads to more effective and innovative outcomes.
So what does all this mean for us, for the listeners trying to innovate?
Well, based on this extensive analysis from AI IdeaBench 2025, the research identifies key factors that currently underpin the generation of useful and impactful research ideas.
These aren't just theoretical points about AI.
No, these are direct, actionable lessons. They can guide AI developers building these systems, but also human researchers, entrepreneurs, anyone involved in problem solving.
Okay, let's hear them. What's the first pillar?
Pillar 1 is crystal clear. Accurate inspirational papers are paramount. Garbage in, garbage out, basically. The quality of your input directly correlates with the quality of your output. This stresses the need for accurate inspirational papers, whether identified manually or using AI for relevant scoring.
So the foundation matters a lot.
Immensely. The more relevant, high quality, and foundational your source literature or background info, the better your AI or your own brain will perform.
For you, the listener, this translates directly. Don't just feed an LLM any old paper or do a quick surface-level search for inspiration. Curate your sources carefully. Use tools, maybe even LLMs, to find the most relevant, influential works, like a chef needing the best ingredients.
Exactly. The second pillar, drawn from models like AI Researcher, is to embrace multi-round idea generation. The research unequivocally shows that ideas should be generated in multiple rounds, with each generated idea archived and used as input for subsequent idea generation.
Don't stop at the first draft.
Never. This iterative refinement is critical for enhancing coherence, expanding thoughts, ensuring stability. It's a journey, not a single shot.
This translates perfectly to iterative brainstorming in your own work. Don't stop at your first idea, even if it feels brilliant. Build upon it. Critique it. Ask, what are the weaknesses? How can I expand this? Alternatives. Generate variations before settling. Mimic that AI refinement loop.
Pillar 3. Evaluate ideas broadly, both internally and externally. The research suggests you need to evaluate the generated ideas by retrieving papers based on both the ideas and the topic. This dual check is vital.
Checking internal logic and external relevance.
Precisely. Does the idea make sense on its own, and does it matter to the wider field? This avoids ideas that are technically sound but irrelevant, or relevant but impractical.
So when you have an idea, don't just assess it in isolation. Actively seek existing work supporting its components and its overall theme. This is your personal feasibility and novelty check. Can you find similar methods that worked? Does your idea offer something truly new? That validation is key.
And finally, the fourth pillar, clarity in framework and components. The research highlights the crucial need to clarify the framework and components of the idea to reduce the difficulty of generation. The clearer the internal structure, the easier it is to develop and articulate.
Break it down simply.
Yes. Clear motivation, concrete steps, expected outcomes. The clearer the structure, the easier for AI and humans to work with.
This is powerful for communication, too. Break down your complex ideas into clear motivations and concrete steps, maybe even anonymized jargon. Focus on function. This forces clarity in your own thinking, exposes vague areas, helps you avoid that SIP pitfall of incoherent structure. Build a robust internal blueprint. Now, let's take these powerful learnings from AI Idea Bench 2025 and create a tangible action plan for you, the listener. How can you apply these insights to your own endeavors, research, business, creative work, project planning?
Okay, step one is strategic source curation. Forget generic searches. Proactively identify and prioritize foundational papers, reports, best practices in your field. Just like AI Idea Bench focused on those top-tier papers, aim for influential, current, relevant sources for your problem.
Use tools, maybe LLMs, to help find highly cited or conceptually similar work.
Exactly. Ensure your inputs are high quality. Don't just browse. Curate your knowledge base with intent. Strong foundation first.
Step 2. Embrace iterative brainstorming loops. Don't aim for perfection immediately. Create an initial concept, then consciously self-reflect on it, like AI researcher. Ask those tough questions. Weaknesses, how to expand, alternatives. Generate 2-3 variations before settling. Constant refinement builds robustness.
Step 3 is about external validation and feasibility checks. For each key component or proposed solution in your idea, quickly search for existing literature or successful case studies. This is your human version of the feasibility assessment. Look for highly cited works validating subconcepts. Does evidence support the building blocks?
This boosts confidence and spots potential roadblocks early.
Precisely. Saves time and effort down the line.
Then, step 4. Deconstruct for clarity. Break down your idea into its core motivation and implementation steps, like the pre-processing in AI Idea Bench. Maybe try anonymizing jargon. Focus on describing functionality and purpose. This forces clarity, exposes vague areas, avoids the CLA-PIP trap. Clear communication strengthens the idea.
And finally, step 5. Peer competition and critique. Share your refined ideas with a diverse group, peers, colleagues, mentors. Your personal baselines. Encourage them to critique across criteria like novelty, importance, feasibility, clarity. This ideas competition reveals blind spots, brings new perspectives, strengthens the concept. Leverage collective intelligence.
These are powerful, actionable steps inspired directly by this AI research. They embody the practical insights promoted by the AI coach by Anil Nathu philosophy. They can truly transform your approach, whether you're building the next AI or just solving a tricky problem.
Absolutely. We've unpacked AI Idea Bench 2025, explored its innovative approach to benchmarking AI-generated research ideas. We've seen how its meticulous dataset construction, that crucial knowledge cutoff, and its sophisticated dual evaluation framework provide unprecedented insights. Insights into the true capabilities and, yes, the limitations of LLMs in scientific discovery.
And this work isn't just about building better AI, is it? It offers profound lessons for human creativity and problem solving, too.
It really does. The automation of scientific discovery isn't just a distant dream anymore. Tools and frameworks like AI Idea Bench 2025 are making it a tangible reality step by step.
With profound implications for the pace and nature of innovation across all fields, it's an exciting time. Thank you for joining us today. Buy the book at the AI Coach website for more insights on artificial intelligence.